Okay, so what we're going to talk about here is sigma notation. So if you take a look at this symbol right here, this is just a Greek letter called sigma. And the sigma is also sometimes called summation notation because it just tells us to take what's after the sigma and to just sum it up. Okay, so let's suppose we have this example right here. Okay, what this is telling us to do is it's telling us to sum up all the values of n, starting at n equals 1 and ending at this value 4 right here. Okay, so if we wanted to write out what this is equal to, we can say that this is equal to, so what we do is we first take a 1 and substitute it in for n. Okay, then we're going to add to that, and we're just going to keep placing in the next consecutive integer. So after a 1, we're going to add on a 2, and then a 3. And then what happens is this number on top of the sigma symbol tells us where to stop. So once we reach 4, we're going to stop. So you can just add these together. So 1 plus 2 plus 3 plus 4 is equal to 10. So that would be our answer. All right, so let's take a look at some more examples. So in this first example, they're telling us to sum all the values of 2i minus 1, starting at an index of 3 and ending at I equals 6. Okay, so let's just take this 3 and substitute it in for I. So when we do that, we're going to have 2 times 3 minus 1. Okay, now we're going to add to that. The next number after 3 would be a 4. So instead of putting a 3 here this time, we're going to put a 4. So we'll have 2 times 4 minus 1. And then the next one will be 2 times 5 minus 1. And the final one we're going to add to that is 2 times 6 minus 1. Now, we know we could stop when we substitute in the 6 because this number on top of the sigma symbol tells us when to stop. All right, so now we just have to figure out what this is equal to. So 2 times 3 is 6, and 6 minus 1 is 5. Okay, then we'll bring down this addition sign. 2 times 4 is 8, and 8 minus 1 is 7. Bring down the addition sign. 2 times 5 is 10, and 10 minus 1 is 9. Bring down the addition sign. 2 times 6 is 12, and 12 minus 1 is 11. All right, so now let's just add these all together. So I'm going to start over here. 11 plus 9 is 20, plus 7 would be 27, plus 5 would be 32. So that's our answer for this one. Okay, the next example tells us to start by substituting negative 2 in for x, and we're just going to keep plugging in the next consecutive integer until we reach an integer of 1. All right, so this is going to be 4 times negative 2 squared plus 4 times negative 1 squared plus 4 times 0 squared plus 4 times 1 squared. And again, we know to stop when we substitute in this 1 because this number on top of the sigma symbol tells us what number to stop at. Okay, so anyway, negative 2 squared is 4, and 4 times 4 is 16, plus negative 1 squared is 1, so 4 times 1 is 4, plus 0 squared is 0, times 4 is still 0, and then plus 1 squared is 1, times 4 is 4. So when you add these all together, 16 plus 4 is 20, plus another 4 would be 24. Okay, our next example has a 3/4 right in front of our sigma symbol. So all that tells us is we're going to find the sum of all of this and multiply it by 3/4. All right, so I'm going to do this. I'm going to first bring over that 3/4, and I'm going to just open up a big parenthesis to show we're going to be multiplying by that. All right, so we're going to start off by taking this 0 and substituting it in for x. So we'll have 0 over 0 plus 1. All right, and we're going to add to that. Now I'm going to plug in a 1. So now we're going to substitute these x's with 1. So we'll have 1 over 1 plus 1. Okay, then we're going to add to that 2 over 2 plus 1. And we're going to add to that 3 over 3 plus 1. And again, we know to stop at 3 because that's the number that's on top of our sigma symbol. Okay, so let's bring the 3/4 down, and let's just figure out what each of these are equal to. Well, first of all, 0 over 0 plus 1 is 0 over 1, and 0 divided by 1 is just equal to 0. So I'm just going to get rid of that so we don't have to look at it. All right, so 1 over 1 plus 1 would just be 1 over 2. And then plus 2 over 2 plus 1 would be 2 over 3. And then plus 3 over 3 plus 1 would be 3 over 4. Okay, so I'm going to bring down my 3/4. And I'm going to just find a common denominator for these fractions so we can add them together. So my common denominator would be 12. So I want to rewrite each of these so we have denominators of 12. All right, well, in order to get a 12 as the denominator of my first fraction, I need to multiply the top and bottom of this by 6. So I'm going to multiply this by 6 over 6, which leaves me with 6/12. Okay, the second fraction, I'm going to have to multiply the top and bottom of that by 4. So 4 times 2 is 8, and 4 times 3 is 12, so we have 8/12. And then the last fraction, we're going to have to multiply it by 3 over 3. So that'll give me 9/12. Okay, so now I'm kind of running out of room, so I'm gonna go this way now. I'm gonna bring my 3/4 over, and when I add these fractions, I'm gonna keep the denominator of 12, but I need to add all the numbers in the numerator here. So 6 plus 8 is 14, and 14 plus 9 is 23. So we'll have 23 over 12. Okay, so now to multiply fractions, you could just multiply across the top and multiply across the bottom. But something I see that simplifies first is, see this 3 right here and this 12? They're both divisible by 3. So why don't we just say, well, 3 divided by 3 is 1. 12 divided by 3 is 4. Okay, now neither one of these 4's simplifies with the 23 on top. So at this point, let's just multiply right across. So 1 times 23 is 23. And then over 4 times 4 is 16. So there's our answer. Okay, our next example has an 18 minus in front of it. So we're going to kind of do the same thing as we did with the 3/4. We're going to just kind of put that in front of all of our work here. So I'm just going to bring it down because I think I'm going to run out of room next to it. So let me bring down the 18 minus. Now, this time what we're going to do is we're going to take a 2 and substitute it in for the k here. So we'll have 4 minus 2 squared. I'm going to just put that in another parenthesis just to group it together. Okay, then we're going to add to that. Well, now we have to plug in a 3. So we're going to have 4 minus 3 squared. Then we have to add to that 4 minus 4 squared. And I'm going to stop here because I've now reached the number on top of my sigma symbol. All right, so we're going to have, bring down the 18, and then minus. Let's just figure out what each of these are equal to. All right, well, since 2 squared is equal to 4, 4 minus 4 is just 0. You don't even have to write it. I'll just put it there. But you don't need to write the 0. All right, so then 3 squared is 9. So 4 minus 9 is negative 5. So technically, you don't even need really this plus sign here, but I mean, I already wrote it, so let me just put the negative 5. It's better just to write 0 minus 5. Okay, and then the next one, 4 squared is 16, and 4 minus 16 would be negative 12. So this time I'm planning ahead. Instead of bringing down plus negative 12, I'm just going to write minus 12. Okay, so now we have 18 minus, well, 0 minus 5 minus 12 is negative 17. So if we have 18 minus negative 17, that's really the same thing as 18 plus 17. So 18 plus 17 would be 35. So that would be our answer here. Okay, let's try one more example. So in this example, they want us to find the sum from where k equals 0 up until 2 of cosine of x pi over 4. All right, so we're just going to start off by plugging in a 0 in for x. So this is going to be equal to cosine of 0 pi divided by 4 plus cosine of 1 pi divided by 4 plus cosine of 2 pi divided by 4. Okay, well, let's just figure out what all of these are equal to. So we have cosine of, well, 0 pi divided by 4, 0 times anything divided by 4 is just 0. So this is cosine of 0. And then plus cosine of pi divided by 4. Well, if we took pi divided by 4 and changed it to degrees, right, we would multiply by 180 over pi. So the pi's cancel off. So 180 divided by 4 simplifies to 45 degrees. So I'm going to rewrite this as cosine of 45 degrees. And then plus, well, let's do the same thing with the 2 pi over 4. If we want to take 2 pi over 4 and convert it to degrees, we can multiply by 180 over pi. So the pi's cancel. And 2 times 180 is 360, and 360 divided by 4 is 90. So this is going to be cosine of 90. Okay, so cosine is 0. Well, let's just think about our unit circle. If we think about the unit circle, let's see, the coordinates of this point would be 1, 0. The coordinates of this point would be 0, 1. I'm actually going to stop here because we're not going to need any more than this for this problem. But cosine of 0, well, here's 0 degrees, and cosine is our x-coordinate, so cosine of 0 is equal to 1. Plus, cosine of 45, that's one of our special angles that we have to have memorized. That's radical 2 over 2. And then plus cosine of 90, well, 90 degrees is right here, and again, cosine is your x-coordinate, so that's going to be 0. All right, so when we want to add these together, I'm going to make the 1 into a fraction, so I can add that with this next fraction. And 0 doesn't change anything when you add it, so we're just going to cross that off. All right, so let's find a common denominator. I'm going to multiply the top and bottom of this by 2. So this becomes 2 over 2 plus radical 2 over 2. And when you add these, just add across the top, so you get 2 plus radical 2, and you keep your denominator. So this would be the final answer.